Good morning. I put 1H notes up last night, but as I was thinking about this, I wanted to do a new note sheet pre 1H just to sort of simplify this thing and make it look a little bit easier before we move on to the actual 1H. So we have this linear function f of x equals 3x minus 1. All right. And again, we could graph it, we could do points. And so x values, we could pick anything we want because linear function has, unlimited domain. So y being equal to 3x minus 1. 3 times 0 minus 1 is negative 1. 3 times 1 is 3 minus 1 is 2. 3 times 2 is 6 minus 1 is 5. 3 times 3 is 9 minus 1 is 8. Okay, so these are all points. So if we were to plot this function up right here, we'd have 0, negative 1 right there, and then 1, 2, and then 2, 5, etc., to sketch that graph, okay? So the graph's going to look like this because, again, as I said in the function basics video, this is a point, 0, negative 1, and this is a point, 1, 2, and this is a point, 2, 5, and this is a point, 3, 8, okay? So all those points are going to make up what the graph looks like, okay? Not really the moral of the story here, just to make sure that we understand function basics, okay? So we have a linear function 3x minus 1, f of x equals 3x minus 1. Let's just talk about if we do a vertical stretch by a factor of 2. All right, so vertical stretch by a factor of 2. How we do that is, remember, we do 2 times f of x. Okay, we multiply the f of x by 2. Well, what is f of x? Well, f of x is 3x minus 1. So this vertical stretch is going to be 2 times 3x minus 1. Okay, so when we simplify it, when we simplify f of x with a vertical stretch of a factor of 2, we'll just distribute 2 through the 3x minus 1 because it's 2 times f of x. Remember, f of x is this whole thing. So the new function is going to be 6x minus 2. Okay, so nice and easy. So now with the 6x minus 2, if we were to look at our points, just take a couple. 6 times 0 is 0, minus 2 is negative 2. 6 times 1 is 6, minus 2 is 4. 6 times 2 is 12, minus 2 is 10. So now we'll see we have different points than what we had originally. Okay, originally we had a graph. We had 0, negative 1, and we had 1, 2, we had 2, 5, etc., etc. So now we see that this thing is vertically stretched by a factor of 2, so at each x value, the y value down here is double what it was up here. All right, so that's a simple one, vertical stretch by a factor of 2. So it's again, I know it's kind of messy, but it's going to be 2 times f of x, right? And since f of x is this thing, we're going to multiply 2 times that thing, because that thing is f of x. And we see that the y values double for the corresponding x values. Okay, you don't have to plot these points, but again, these points are all what make up the line that we graph if we go to graph on Desmos. Okay. All right, so let's look here. We have translate f of x 5 units left. Okay, so f of x, again, we said is 3x minus 1. All right, so 5 units to the left, if you recall, it's going to be f of x plus 5. Okay, because inside the parentheses with the x, we add when we go left. We subtract when we go right. It's the opposite. Go back to the 1C notes. Okay, so we reduce that down. F of x plus 5. Well, now we're still going to take our f function, which is 3x minus 1, but now instead of x, we're going to have x plus 5. because x plus 5 is now the new input. Okay, it replaces the input x with the input of x plus 5. All right, simplifying this down, we have 3x plus 3 parentheses x plus 5, which is 3x plus 15, and minus 1, which is going to give us 3x plus 14. Okay, so again, in our original 3x plus 1, or 3x minus 1 thing, excuse me, we had 0, negative 1, we had 1, 2, 2, 5, and so on and so forth, okay? In our new one, when the function is translated 5 units to the left, we have the equation 3x plus 14. Well, how does this look? 3 times 0 is 0, plus 14 is 14. 3 times 1 is 3, plus 14 is 17. 3 times 2 is 6, plus 14 is 20. So we'd have the points 0, 14, 1, 17, 2, 20, etc., etc. Okay. Again, so we're translating 5 units to the left. The x plus 5 becomes the input for x. So we plug x plus 5 in for x, kind of like we did on 1g. All right, and now when we actually simplify the equation, we can do that. Just doing a little distribution and simplify the equation down there. Okay, let's do one more here on the video with multiple things. This is where it gets a little tricky. And again, I put it on the video for 1h, but I figured it may be better to look at this in some small little chunks before we go to 1h. So this is sort of our pre-1h notes to help maybe at least make us a little bit more comfortable with this stuff. All right, so here we have f of x is equals 3x minus 1. All right, so vertical reflection, vertical compression by 1/2, and translate up 4, okay? So vertical reflection, all right, so now we're going to have a negative in front of our f of x. We're going to compress it by 1/2, so we're going to have negative 1/2, negative 1/2 f of x, and translate up 4, so we add 4. All right, so vertical reflection and vertical compression, so we multiply our f of x function by negative 1/2, negative for the reflection, 1/2 for the compression, and add 4 on the outside. So again, let's just look at a simple substitution here. So f of x is equal to 3x minus 1. So 3x minus 1 is going to go in for f of x. So we're going to have negative 1/2, 3x minus 1, plus 4. All we're doing is taking our compression notation, okay, f of x right there, and plugging in what f of x is equal to, okay? So we should know that anything that's equal to something else, we could substitute them out. So we're just taking what this looks like when we did our 1c notes and plugging in the actual function for what f of x is because they're equal to each other. So simplifying this function out, negative 1/2 times 3x is going to be negative 1.5x. Negative 1/2 times negative 1 is going to be positive 1/2, so plus 0.5. And then we're going to add the 4 on the outside here as well. All right, so negative 1.5x plus 0.5 plus 4. That'll give us negative 1.5x plus 4.5. Negative 1.5x plus 0.5 plus 4 is negative 1.5x plus 4.5, okay? So again, our original function, 3x minus 1, we have 0, negative 1, 1, 2, 2, 5, so on and so forth. plot any point you want. Our new function, negative 1.5x plus 4.5. Well, let's look at what we have table-wise here. 0. Negative 1.5 times 0 is 0, plus 4.5 is 4.5. Okay. 1. Negative 1.5 times 1 is negative 1.5, plus 4.5 is 3. 2. Negative 1.5 times 2 is negative 3, plus 4.5 is 1.5. Okay, so these would be the points that would make up our graph of f of x after it's vertically reflected, compressed by a half, and translated up 4. So that's that. Maybe take a minute and try these last two problems on the back. I give you a new f of x of 5x plus 8 and 2 problems down there. We'll see if we can rewrite those functions and then substitute and actually come up with the equation for it. That's what I got. And you guys take care and let me know if you have any questions.